Within any programming language, the flow of code or the flow of execution within the code usually works from top to bottom. If you take a look at the way the code executes within a method or a function within a program, the first line of code starts the execution, and the code will execute each subsequent line until it reaches the end of that method or the end of the program itself. That's the typical way that most applications will function, with the exception of some kind of a change in that program flow. And when we refer to a change in program flow, that means that we are causing our code to execute in a different branch or a different location. So program flow is very important because a lot of the times in your application, your program logic won't necessarily work from top to bottom within the code structure itself. So we have various program flow elements that allow us to alter the direction or alter the program flow within the code. So the execution path will change. Let's take a look at some of the program flow elements that C# has available for us. One thing that you will find very quickly is that computers are really great at doing things over and over and over again without complaining about it. So repetition is built into the programming languages with various structures that allow us to repeat execution of code within our program. Now, we might want to do repetition within code as we count up through a number of different aspects. For maybe we're doing a sum, or we want to do an average of student grades within an application. And repetition is a great way of doing that. C# provides us with different looping structures, and a loop means to repeat or to iterate over and over again. And the first one that we'll see an example of when we step out to Visual Studio here shortly is something called a for loop. And a for loop basically says, what I want you to do is execute whatever is within these curly braces for as long as a certain condition remains true. When the condition evaluates to false, then our loop will stop execution. C# also provides us with something known as a for each loop. And a for each loop is a little bit different from a for loop in that it relies on specific components within the C# language and the .NET framework that allows it to iterate across collections of objects. So you'll primarily use for each with collections of objects. Essentially, it just says for each X of something, for each object of a specific type, I want you to do something. And this becomes very important because when you're creating applications, you might have a collection of values or a collection of objects that you want to iterate over and perform some task, but only if the object meets a certain criteria. So a for each loop, it gives you the ability to actually work with that. C# also supports something called a while loop. And a while loop is basically a way of saying, while this condition is true, go ahead and perform some task. And when the condition is no longer true, or while a condition is not true, we'll stop doing that. Another one that is similar to the while loop is one called a do while loop. And a do while loop simply says, I want you to perform something while this condition remains true. There's a subtle difference between the two, and oftentimes it confuses new programmers, but we'll show an example of that when we step out into Visual Studio as to what the differences are between those two. Now, outside of repetition, we also want our applications to have the ability to have some form of built-in logic, and decision structures provide us with this functionality. A decision structure allows us to tell the code to evaluate a condition and to execute a different branch of code based on what the result of that evaluation might be. C# provides something called an if statement, and within the if statement we have other items that we can use for alternative scenarios, such as else if or else. We'll see examples again of those as we take a look at the demonstration in Visual Studio. But essentially an if statement says, if a condition is true, then I want you to go ahead and execute something. Else, if this part of the condition is true, I want you to execute something else or do some other code execution path. And we can include a final else clause which says if everything before is not true, then I want you to do something. So in other words, all previous cases may be false. Another cleaner way of dealing with multiple conditions that we want to test is something called a switch statement. And a switch evaluates a bunch of different cases, and each one of the cases are essentially equivalent to a single if statement. We evaluate the case against a value we pass in, If the case and the value match, then we will execute the code within that. So let's step out into Visual Studio, and we'll take a look at what each one of these different program flow structures allow us to do within our code of execution.